if collision is perfectly inelastic. Now what will happen to the particle? It'll come and will get stuck to the rod. Okay, now work out this. I'll give some time, 2 minutes time I'll give it. Earlier it was the elastic collision. No? So what will happen now in this case? It will get stuck to it. Mass of the rod is m, mass of the particle is this one, m. Length of the rod, you can write equal to L. These are very popular. Almost you check the advanced, no? There are some 14 times they asked, not 1, 2. 14 times, all different, just about rod, this one. But the idea is same, all that 14 numerical, the idea is same. It's a very popular, this one. After collision, what happened to rod plus particle? And now the very first question comes now, about what point the angular momentum should be conserved, because there is a core idea, no? What point I should pick up? But what point the rod plus particle will rotate? Thus it will rotate about any point. Will it rotate about any point? No, it will rotate about the center of mass of the system, where the center of mass will come here. Then I should show everything with respect to center of mass. What is this earlier problem? You shown the velocity of the rod VO, omega O. Now you're writing omega C, BC. Problem to problem, things are changing. Any reason for that? The basic idea is the basic idea is like, if a rigid body is set free to rotate, it will rotate about what? It will rotate about center of mass, no? This is one basic property of rigid body. If a rigid body is set free to rotate, it will rotate about center of mass. It will rotate about center of mass here. Then, about what point angular momentum is conserved? Angular momentum is conserved about any point on the rigid body or about any point on the ground. But about which point will conserve? About what point the rod will rotate, about that point, if you conserve angular momentum, it will be very easy for you to write the equation. Then during collision, what are the things? Impulse will act. And impulse. And we are bothered about center of mass here. So applying conservation of linear momentum, initial linear momentum, final initial momentum, mu, final momentum, m plus m into bc. So what is vc equal to? U by 2. This is one thing. Next, after this, what I should apply conservation of angular momentum. About what point? About c. LCZI is equal to LCZF. But sir, angular momentum is conserved about any point. Yes, it is conserved about any point. But after collision, what happens? The rod plus particle will rotate about center of mass, not about O. Because it's like it's a rigid body free to rotate, so it will rotate about center of mass here. So I'll consider about what point the rod is rotating. About that point, I'll consider angular momentum. Now this should be equal to mu. What can be distance AC here? AC should be equal to L by 4. AC should be equal to L by 4. So mu L by 4. Initial angular momentum clockwise. Final angular momentum IC omega C. This is of what? IC is of what? IC is mu L by 4. What is IC? Moment of inertia of the rod, ml square by 2L plus m into L by 4 whole square. This is for rod. Okay, fine. Then for particle, how much it is? At what distance from the axis of the particle at a distance L by 4? So m into L by 4 whole square into omega c. Solving all this, already we know Vc. Solving this, we'll get the omega c. So put it clearly. This is for rod. This is for particle. Got the idea now? So this will be, there's a core central idea. A rigid body is set free to rotate. Sir, what do you mean by free to rotate? You see that there's no any, it's not a fixed axis rotation, the rod plus particle. It's a axis is, it can rotate about any point, but where the center of mass is C. But sir, like a, you can ask C, like a, better to think in a very random way, nothing wrong. So this impulse can set up also on about O. At the same time, impulse will set up also about O. So plus JL 0. Similarly here also, sir, like plus JL minus JL. Then why do it will rotate? It should just move, no? It should have only translated motion. What is the net angular impulse? 0. As a net angular impulse is 0, initial angular momentum should be equal to final angular momentum. Now you ask questions of what makes the rod to rotate? The same impulse only. This impulse, what it will do? It will decrease the linear momentum of the particle. The same impulse, what it will do? It will impart momentum and also set up angular impulse. So here what happened? Again, the impulse of deformation, reformation occurs. And finally what happened? We see this condition. I think as a student, you should really analyze here. What actually happens? The ball or the particle, this when it goes and collides, it will undergo deformation. But sir, you said this is a rigid rod. Yes. Rod is rigid. What about particle? Particle also rigid because we are applying quotient of restitution means some sort of what should happen? Deformation, reformation should take place here. So that will do for particle. But sir, you said particle is particle means small body it is. So when you define quotient of restitution, S, you must able to analyze here. So since net angular impulse is 0, so therefore finally it must have some angular momentum. So that angular momentum about what point? About C. Any reason for that? Because a rigid body set free to rotate will rotate about center of mass. Like this, what happened? We'll get the omega C. What is the velocity of point A after collision? Can we find out that also? Is what is velocity of point A after collision? Will be L by 4 omega C plus Vc. What is the velocity of point B? Vc minus 3L by 4 like this. You can define speed of any point. What will happen to the rod? Will there be any stress in the rod just after collision? Will there be any stress as you go back to the circular motion? If a rod rotates about a point, so what happened to tension? Will be 0, no? 0, non-zero, will be non-zero. So the tension in the rod just after impact will be non-zero. And we know how to calculate. I think you got some questions in previous exams earlier in circular motion. Just after impact, what will be the tension in the rod? Will be non-zero. Just after impact. Or after impact, better they write. After impact. Tension in the rod will be. These are the more dangerous things. That's why you should make observations. So why the tension you brought it? Why the tension? Or say some stress or some force in the rod. Okay, now I think a little bit, let me take easiest example here. Now, if the rod is rotating, so it'll be quite very easy, no? This will be, you look at the center of mass of this part of the upper part of the rod will be M, and M omega 2 square L by 2 will try to pull out like this. Similarly here, M omega 2 L square, omega 2 L square by 2 will try to pull out. So these two forces, centrifugal forces, when they're trying to pull apart, so there'll be stress will be generated in the rod. So after collision, what happens as the rod is rotating, it will have, due to centrifugal force, there'll be tension. Why do this tension will be there? Due to radial outward force. Now, is there any point on the rod which will be at rest? Instantaneous rest. How? Yes, it can be brought here also, instantaneous rest. Then how to calculate that point? Vp is equal to Bc minus R omega C. What is anybody value of omega C? Just solve this, give omega C. We'll wind up that idea also. 3u by 5l. Yeah. No, after getting thank you. Then Vc is how much? Vc is u by 2. 3u by 5l. This is R into a point which will be a test. So what is point P? Instantaneous center. Should be 0. So solving this, R equal to how much will get? 5L by 6. From where you are measuring this R? Next question comes from where you are measuring. So let me give a separate diagram. This is the center of mass, no? This is Vc and this is omega C. The R is what? I'll measure from here. R equal to 5L by 6. So that particular point will lie on the rod or lies outside the rod. The particular point whose velocity will be 0 at that instant. 5L by 6 should be less than L by 2. Okay, should be less than 3L by 4. So 50, no? So it will be like a 0.8L. So will it lie outside or anybody? R will be greater than 3L by 4. Yeah, it will lie outside. The point P will lie outside because R, so this R is in fact greater than 3L by 4. So where do that point will lie? Not on the rod. Means what is this instant center, sir? Where is that? There is no rolling. Why you brought instant center? That's the first question what you can ask. There's no rolling, sir. Why you brought instant center? You stand on the ground. What is the comment you put it? Center of mass is moving with a velocity u by 2 and all points are rotating about center of mass. You come and stand at instantaneous center. Then what you should predict? This U will write able to see the screen? Okay, fine. U will write this equation like this. Person on the ground, no? Then same problem. Let this be so here if it is the incident center, then what you should show? You have to just show it that all points are. So don't think that only instant center is for rolling object and anywhere I can bring it. So I think this is what actually instant center, no? Don't get confused. I just brought an equation Finally, I calculated R. R is in fact greater than 3L by 4. I'm just showing it outside here. So the rod in fact rotates about a point P. Then if you stand at tension center, then what you see that all points are rotating about center of mass, only rotating motion. Who will see this diagram? Person on the ground. The person at tension center. Person at tension center, what you'll say that all points are rotating about center of mass with angles to omega c. Then what this person will comment? Center of mass is moving straight with a velocity vc. Then all points are rotating with omega c about center of mass. Both comments are totally different. Center of mass is moving horizontally with velocity vc, and all points on the rod are rotating with angular velocity omega c about center of mass. What is this comment? This comment will be all points are having only rotational motion about instantaneous center P. Rotation motion are having only rotation motion. That angular velocity I'll mention with angular velocity with angular velocity omega about this is very important. Conceptually, I will try to push you to these ideas, because what else I can ask you? So only to trouble no. So what students, what happen? What happened? Only for rolling motion you start thinking, no, I can apply for anywhere here. Just see once, we'll take the next case. And that's omega c's. I'm showing about C. Now I'm showing about P. This diagram is just to show you that somewhere on the rod I assumed it, but later on what I came to know, the incident center is not on the rod, it lies outside the rod. Let it be no problem. And this is O, no, midpoint of the rod. Okay, let's take the next condition.